for the gutters. Actually, flashing is a problem. I don't think that it needs rust arresting, but actually all this flashing should be done properly, not with asphalt, but with a flexible moving system that can move with the crack, move with the expansion and contraction of the metal. Regarding this area, it's leaking all along this leaking as well. So the leak could be actually from the accumulation of leak of these rivets. So rivets should be encapsulated, and also these ones, because this is silicone, this one should be also flashed with the same technique. Actually, also these connections should be flashed. Actually, this roof meant to be a clipping system, but I think in a certain point of time, rivets has been established, been added to the system, and actually this would compromise the integrity. Means that the rivet should be encapsulated if it is needed. This is another scope. This gutter has been changed like 2 years ago with stainless steel. It's very good stainless steel, no problem. The only problem is the seams. The seams is actually has done really in not a professional way. So we'll do reflashing for these seams with the same technique. The 3 layers of seam guard, poly core, and seam guard. Also including this one, because water might seep inside the parapet itself. Another horizontal seam on this L-shaped roof that needs flashing, and you can see how the color differential in the seam means that the water is actually keeping there in between the two parts. So actually water is coming inside from these seams. Again, here this is the other gutter. So it is L-shaped. So this and this. So here is the gutter, another one, and here as well. And it is very good condition except the joints. So joints should be done, also flashed. Is actually this area, it is leaking. So we have different seams here. We have the seam between the wall and the flashing and the metal flashing, and another one with a very heavy rain. Actually, the water can be pushed inside from the second layer. This corner, and also this third one can be sort of a water leak source, but this one is the least one that might leak. So in our proposal, we'll only do this flashing and we'll skip this and see exactly if the water is still coming. Then this is the seam. Actually, the 3 of them might be the source, or are actually the sources for leak, but actually this is more severe. You can see here that even the rivet with the gasket is not tight. Also these joints also leaking, and when we put these 3 layers of flashing in these lines, actually it will become like seamless flashing, as if everything will be like one material. Here also, this has been done in cement to prevent water being stagnant here on top of this beam top. It works okay, but start to crack, and this crack also can bring water inside. So with this, with paint with top seal, TS commercial grade, and this is also 100% rubber coat. two coats from this to from here to here, for example, would actually prevent water to come inside, so there's no way for this cement to be wet and dry. This is the cycle that destroys the cement and actually introduce the cracks. So there's another scope. Actually, the leaking is the strip here, the flashing strip, and as we said, that there is one seam between the metal flashing and the wall, and another seam between the metal flashing and the other metal flashing down there, and also these are vertical seams that actually would be the cause for the leak. This is for this side and the other side, and there the gutter also problem would be the seams as well. This has been done with asphalt flashing and failed to stop the leak. So this membrane roof, concrete membrane roof, there's lots of leak from the cooling towers anyway, or the roof, and also the stagnant areas here with the stagnant water destroying the membrane. And we can see like trials of treating this with these areas. Water stagnant can be seen as a stain, and with concrete roofs it is really very unlikely to know where is the area that leaks. So the only way to treat this actually is to treat it all. With the areas that is low in level like this will be rectified. So in this particular area we might do rectification for the slope on top of the membrane, and then we have a complete solution, which is 2 layers of TS commercial. This is 100% rubber material and reinforced in between with the same textile, 100% polyester textile. It means that it will make like a sandwich membrane, reinforced sandwich of membrane that will be covering everything, actually imitating the same curvatures, the same everything, and actually flashing to the wall as well. This area of stagnant water should be rectified in a way that we minimize the bond, the water bonding. We cannot actually eliminate the water bonding 100%, but at least we minimize the thickness of the bond, so it will be evaporated easily. We anticipate also that there's a problem on the edge. The edge should be lower a little bit to be able for the drain, for the water to drain to the gutter, to the metal gutter. That would actually also need flashing with the same technique of seam guard, polycore and seam guard. But here, for example, they had to actually cut in the membrane and cut in the slab a little bit, like do some hacking to give the water a possibility to slide into the gutter. You can see the stain here. The stains that actually introduced by having the water stagnant here for a long time, so it starts to evaporate, but leaving the salts of the water, the salts contained in the water, and actually having this stains. It means that this is lower part. Actually, there's like areas for previous attempts to flash with another torch membrane, but it doesn't work definitely. So these areas should be rectified and then coated with our reinforced membrane, liquid membrane. Many patches has been introduced, and this actually compromises the integrity of the membrane itself. So wall cracks is the problem here, one of the scopes. So you can see it all over the two buildings, and the cement material has been used. This is not actually flexible enough to work with the movement of the wall. so it gets crack again, like this one for example gets cracks again. But what we are going to do is actually to flash this with our seam guard and 2 layers, and in between reinforcement textile, 100% polyester textile, and the 2 materials like the seam guard is like 100% rubber material. So it actually will cover and actually will be flexible enough to move with the crack, and the crack will not appear again. Here they open the crack and then they fill it with the material. This is not actually cannot work because we need to bridge the crack from this side to this side and cover it with reinforcement. Then the crack will not appear again. The crack will not open again. Actually, we needed to try to know exactly how much the cracks in the wall. So this elevation as a sample has been scaled, and then all the cracks has been traced to know exactly how many meter run of cracks do we have in this wall, and according to this we relate this rate to all. We applied the same rate on the whole elevation for this building or for the other building. So this is how we do this. We do it as accurate as we want to make sure that it is reasonable calculation. So another scope, which is the actually entry point, the entry seam, the seam between this chimneys and inside is also leaking. So all this periphery actually needs the same flashing. Another scope, if we have seen this projection has the roof, this small metal roof, and the flashing has problem, and also all the wall flashing, all this corner flashing are also leaking inside, and also the flashing of the top. We'll use the same technique, 2 layers of seam guard and in between the reinforcement, and this would actually bridge between the wall and the different material of the roof or the glass or whatever other material that is in contact with the wall. Then we'll bridge this, we'll flash and bridge these corners. So another leak here in the canopies. So this one leak, and the other one is here. These are so for this leak is actually the between the glass and the aluminum. So this is flashing can be done with polyprene or sealant. And on top of this is the one that is leaking as well. So canopy. Yeah, and then here the corner of the room that we have seen it from inside. This is the area that is leaking to the corner. Actually, the silicone is giving up. See here how the silicone is very thin layer without reinforcement. It's very breakable. Very breakable. Here, for example, this one here, like the flashing, it should be tightened, but actually all this is spinning now. All this spinning. So what we are going to do is also flash this with reinforcement flashing.